Hello, grade 7. Welcome back to our online class. In this video, we're going to talk about cardinality of a set and set relationships. Let's have this one first. Given a number, we can identify that number as cardinal number, nominal number, or ordinal number. What's the difference among these three terms? When I say nominal, a nominal number names a person or object. If you see a jersey with a number of 30, we can remember or we can think of Stephen Curry, right? Therefore, the number 30 names a person and it's a nominal number. Ordinal number tells the position of a person or object. Examples of nominal numbers are first, second, third, fourth, and so on. And cardinal number answers the question, how many? How many students are there in 7 tessellations? The answer is 26. There are 26 students in grade 7 tessellations. Therefore, the number 27 is an example of a cardinal number. And that's what we're going to talk about in this video. What is cardinality of a set? Or what's cardinality of set A? The cardinality of set A is just the number of elements in set A, denoted by n of A. If you encounter this kind of notation, it means you're looking for the cardinality of a given set or the number of elements in a set. For example, I have here set A, and set A is the set of continents of the world. There are 7 continents of the world, namely Asia, Africa, Oceania, Europe, Antarctica, North America, and South America. There are 7 of them. Therefore, the cardinality of set A, written as n of A, is 7. The number 7 here is the number of elements we can find in set A. Another example, number 1. Let M be equal to a set containing math. The cardinality of set M, written as n of M, is 1 because there's only one element in set M, which is math. Remember, in set, when you write the elements, you are going to separate each element by a comma, right? Number 2, T is the set of single-digit prime numbers. What is the cardinality of set T? What is the number of elements in set T? So the first thing we're going to do is to determine or identify the numbers, single-digit prime numbers. And these numbers are 2, 3, 5, and 7. There are 4 single-digit prime numbers. Therefore, the cardinality of set T, written as n of T, is 4. Again, 4 is the number of elements in set T. Number 3, A is equal to the set of all x such that x is an element of the set of natural numbers where x is greater than 2 but less than 6. In this example, we have to identify first the natural numbers between 2 and 6. And these natural numbers are 3, 4, and 5. 3, 4, and 5 are the natural numbers between 2 and 6. There are 3 of them. Therefore, the cardinality of set A written as n of A is equal to 3. Okay, let's proceed to this diagram. Given a set can be classified as finite or infinite. When we say finite, the cardinality of a particular set is known. Otherwise, a set is considered as infinite. Next, if a finite set has only one element, then it is considered as singleton or unit set. If a finite set has no elements, then it is called as empty or null set. And there are other finite sets with two or more elements. Next, let's have set relationships. In this topic, we're going to talk about universal set, denoted by U, subset of a set, equivalent sets, and equal sets. Let's start with the definition of universal set, or the U. Universal set, or the U, is the set that we are going to consider in a particular discussion. For example, U is the set of whole numbers less than 10. This is our universal set. This is the only thing that we are going to consider in our discussion. We're just going to consider whole numbers less than 10. Okay? And the whole numbers less than 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the elements in the universal set. And there are 10 of them. Therefore, the cardinality of the universal set in our example is 10. Okay? Next, subset of a set. Subset can be understood as a portion of a set, just a portion. Just like here, set A, whose elements are 807. Remember that 807 are also elements in the universal set. Therefore, we can conclude that set A is a subset of U. B is also a subset of set U because every element in set B is also an element in set U. C is a subset of U because every element in set C is also an element in set U. Remember that A, B, C are just portions of set U. Next, let's see the difference between equivalent sets and equal sets. Take note of the notation we use to denote equivalent set. It's like this, and the notation we used to denote equal set. Equivalent sets are sets with the same cardinality. In other words, two sets are considered as equivalent if they have the same number of elements. B has 4 elements. C has also 4 elements. Therefore, B and C have the same cardinality. Therefore, B is equivalent to C. In this example, we don't have equal sets because when we say equal sets, these are sets with the same cardinality and same elements. So there are two things that we have to consider for equal sets. We have to make sure that both sets contain the same elements and the same cardinality. B and C do not contain the same elements. Therefore, B and C cannot be considered as equal sets. Given a set, usually the given set is our universal set. And we have here a portion of this set which is called subset. And a subset can be considered or classified as proper subset or improper subset. What's the difference between the two? If a subset is not exactly the same as the given set, then it is called proper subset. If a subset is exactly the same as the given set, then it is called improper subset. And another thing is equal sets are always equivalent sets. If two sets are equal, then it follows that they are also equivalent, but not the other way around. Equivalent sets are not always equal sets. Let's have our final example. Given the following sets, A, B, C, and D. Set A has 4 elements. Therefore, I can say that the cardinality of A is 4. Set B has 3 elements. Therefore, the cardinality of B is 3. Set C has 4 elements. Therefore, the cardinality of C is 4. Set D has 4 elements. Therefore, the cardinality of D is 4. Based on the given sets, I can conclude that set B is a subset of set A. Written this way, set B is a subset of set A. This is the symbol for proper subset. All the elements S, A, and R are also elements in set A. That's why set B is a subset of set A. Okay? B is also a subset of set D because all elements in B are also elements in D. I can also say that set A is equivalent to set C. Why? Because A and C both have the same number of elements, both have the same cardinality. A and D are also equivalent sets because they have the same cardinality. C and D are also equivalent sets because they have the same cardinality. Another one, A is equal to D. A is equal to D because set A and set D have the same cardinality. At the same time, they contain the same elements. Okay? And set A is a subset of set D because every element in set A is also an element in set D. What kind of subset? Improper subset. Because these two sets are equal. I hope you learned something from this video. If you still have more questions, I can entertain your questions during our Zoom sessions. Bye-bye. See you in my next videos.